Hi everybody. In this video, we're going to look at the circle theorem involving angles in the same segment. Before we work through these two questions, I want to show you how you can discover this for yourself. If we go to GeoGebra, so we'll create our circle, we'll click on circle with center, we'll click our center, and then we'll create the circle. We have point B, but we need another point on the circumference. This can go anywhere. I'm choosing mine here. And now we need to create a chord. So if we click on segment and we choose 2 points on the circumference, I'm going below the center, but you could go anywhere. So now we've created 2 segments. This is the minor segment below the chord, and we've got a major segment above the chord. We're going to look at how angles in the same segment change. So we'll click on line segment again, and we want to draw an angle to B. So we'll go from B to E, and then we'll do the same for point C. So from E to C, and from C to D. So now we've created 2 angles at the circumference of our circle in the same segment. We want to measure these angles. So we'll go to More, we'll choose Measure Angle, and then we go from E to B to D, and from E to C to D. I'm going to move these so you can see them more clearly. So at this point, what I encourage you to do is to move points D and E around the circle. See what happens to the angles at B and C, and then try and describe this relationship using a circle theorem. You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So if we move point D around, you can see that the 2 angles change, but remain equal to each other. If we move E around, again, they're both different angles, but they are still equal to each other. And if we move point C, if we go into a different segment, you can see that they're no longer equal to each other. So we'll put them back into the same segment. And quite often you'll see this circle theorem without the line D to E, so we can hide this. And they still remain equal to each other. So as a circle theorem, this is called angles in the same segment are equal. Do you think this will also apply to the angles at D and E? Do you think these will be equal to each other? Well, if we draw a chord from B to C, we have a minor segment here and a major segment. So these 2 angles should be equal to each other. If we measure these, we'll go from B to D to C, and from B to E to C. I'll make them over here. And again, you can see that the 2 angles are equal because they are 2 angles in the same segment. So if we go back to our notebook, we'll look at how we can apply this circle theorem. Okay, so back to our notebook. We know that angles in the same segment are equal. So if we draw a chord that splits this circle up into 2 segments, we've got the minor segment here, the major segment here. Then we know these 2 angles are angles in the same segment, so they'll be equal to each other. So angle A will be 68 degrees. Okay? For this question, we can draw a chord here, and then we'll have 2 segments, this segment and the major segment. So which angle do you think will be equal to this 34 degrees? So this will be angle E. And we can draw another chord. So now angle 40 and D are in the same segment. So D will also be 40 degrees. As we work through these questions, we won't continue drawing this chord. We just need to visualize that each of these are angled in the same segment. Okay? Let's try some more questions. So if I work through this question, and you can try these 2. So we know this is an isosceles triangle, given by these 2 lines here. So F and G will be the same. And using angles in a triangle, they must both add up to 70 degrees. So each of them will be 35. And we know that H and F are angles in the same segment, so these will both be equal, so H will also be 35 degrees. The same is true for G and I, angles in the same segment, so I will also be 35 degrees, okay? Do you want to have a go at this one and this one? You can pause the video and come back when you're ready. Okay, so I'll come back if you had a go. We know they are both isosceles triangles, and angle B is in the same segment with this 32. So angle B will be the same, 32 degrees. And because they're both isosceles, these will also equal 32. Using angles in a triangle, we can work out the angle at the center as 180 take away 2 lots of 32. So 180 minus 64, which will give us 116 degrees. So now we can work out angle C as 180 minus the 116 angles on a straight line, and this will be 64 degrees, okay? For the next one, we can use vertically opposite angles here and here. These will be equal, so this will also be 38 degrees. Then we've got angles in the same segment with K and this 38, so we'll have another 38 degrees. We'll have vertically opposite angles here and here, so the angle at the center will be 74. So J will be the same as K, which makes sense because we know it's isosceles as they both share the same radius. So J will also be 38 degrees. Let's try some more questions. So these two questions follow on from the previous lesson where we found the angle at the center is double the angle of circumference. Do you want to try and work out angle N in this diagram and angle M in this one? You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So we're going to combine angles in the same segment and the angle at the center being double the angle at the circumference. Using angles in the same segment, we know that these two angles will be equal, so this will also be 62 degrees. But to work out angle N, we need to identify that we've got a 180 degree at the center, which means the angle at the circumference here will be a right angle. So we've got a right angle triangle in this semicircle. So angle N will be the 180 minus the 90 plus the 62. So 180 minus the 152, which will give us 28 degrees, okay? So angle N is 28 degrees. To work out angle M, we have the angle at the center is 180, so this angle will be 80 degrees, and this will be perpendicular. So now we can work out this angle using angles in this triangle. So we'll have 180 minus the 90 plus the 24, which will give us 66 degrees. And that will be the same as the other one in the same segment. And now we have angles in this triangle. So M will be the 180 minus the 66, add the 80. So minus the other two angles. So M works out as 34 degrees. Well, thank you for watching. I hope you found that useful. If you want more practice on this topic, you can download the worksheet and view the online lesson from my website, mrmathematics.com. I'll leave a link in the description below.